Alrighty, so today in 3.5, we're going to go over binomial probability distribution. So in binomial experiments, it's four things we have to remember. So it consists of n trials, so sample calculations that n is greater than 1, and can contain multiple of these trials that we can see. Each trial has two outcomes, either a success or fail. It's kind of like our Bernoulli, but instead of heads or tails, it's success or failure. The outcomes are independent from each other, so independent outcomes. And our last one, we know that that probability is constant from each trial. So we have an example. A fair coin is tossed 100 times. So we know that n equals 100. Our outcomes are heads, tails, right? Each process is independent, and the probability of success, we can find that would say success is h, is heads. So probability equals probability of heads occurring equals 0.5 for all trials, or half. And for example, let's say because it's 100 times, our random variable of h in 100 tosses, we have x binomial 100 times 0.5. So 100 is the number of tosses, and this is the probability from each trial. So we know that our binomial random variable is going to be, right, defined as x by number of success in n trials, and it's denoted by x binomial n and probability. Right, another formula we can use as well to define this is p equals x equals k, or n k p k 1 minus p n minus k, or nomial factors n over k n minus k, right, times pk, continuing below here, 1 minus p n minus k. Some formulas we're going to consider, right? Mean of x equals ex n times p. So number of trials times probability. Variance of x equals same thing, n times p, but we also multiply in 1 minus the probability. In standard deviation, we get by square rooting our variance 1 minus p. So square root it. Right? So as we go down, right, we also have our formula, right? If we have 3 binomial x n p equals probability of higher case x smaller greater smaller than lowercase, and that just means p x equals 0 plus p x equals 1 dot until we have a final value of p x equals x. So how many times of the sum of value of our binomial? So an exercise we have below, a defective rate of one product is 10% in one company. Assume the product is defective and is independent to the others. So we have to find 6 randomly selected products, how likely only one is defective. And for the second one, 6 randomly selected products, how likely at least 2 are defective. So we're going to go through the first one first. Right, so our outcomes are defective and non-defective. Right, and then we know that our binomial probability is we have 6 randomly selected products, and the factor is 0.1, which is just 10%. Substituting the formula of px equals 1 equals n k p k 1 minus p n minus k, we get 6, 1, 0.1 to the power of 1, right, since k is 1, multiplied by 1 minus 0.1, 6 minus 1, equals a factorial of 6, 1, 6 minus 1, and times that by 0.1, and 0.9 power 5. Our answer is 0.3543, so 35%. Our second part, probability that px greater or equal to 2, right? So you have to do all the sums of p2 plus p6. And then we get 1 minus p0 minus p1. We get 1 minus 6, 0, times 0.1 to the power of 0, times 0.9 to the power of 6, times different values, 0.1, 0.5, 9 to the power of 5. Sorry, multiplied. And we get an answer, 1 minus 0.5314 minus 0.3543, and our answer is 0.1143. Another problem we have below is customers at a gas station paying with credit card, debit, or cash. 2 questions are, among the next 100 customers, what are the mean and variance? And the same thing among the next one, but why won't they pay with cash or debit card? So go through the first one first. Right? So number paying without debit is X, Bernoulli, 100 because that's our sample, and then we look at our table, so debit is 0.2, use 0.2 for the situation. EX equals N times P equals 100 times 0.2 equals 20. Variance, same thing, but now N times P, 1 minus P equals 100 times 0.2 times 1 minus 0.2, and we get 16 with this value. Standard deviation equals the same thing, but our value, square root. So square root 16 equals 4. Pretty simple. So in our second one, we do the same thing, but now we have a value of next 100 customers. What is the mean variance that don't pay with cash, right? So we have these values of same thing. We use the same formula. EX equals 70, right? And we get that by 100 multiplied by 0.3 equals 70. So we're using that for our calculations. Sorry, not 0.3, I apologize, because that's 30, times 0.7, since you're adding 0.5 and 0.2. And then as we move on, do the same thing for variance, but Vx equals 21. Hope you have a good day. Take care.